All right. So we have this thing called the discriminant. Okay. So what kind of use does the discriminant have for us? If I can't trip over my tongue there. It has nothing to do with discrimination. Totally different discussion. However, it does help us separate our answers into a couple different categories. Actually, 3 different categories. Now, we've been solving all these problems, using our quadratic formula and whatnot. And sometimes we get nice numbers, right? Sometimes we get imaginary numbers. Sometimes we could get answers like 1/2 plus or minus radical 3 over 2. And that's not a nice number, but at the same time it's not imaginary, right? Yes? Meaning, if I typed this into my calculator would say error because it has an I. This one, if I typed it into my calculator, either the plus or the minus, it would give me a decimal value. All right? Because these 2 answers are what we call real numbers, not real hashtags, real numbers. And then we have our imaginary ones. What's the difference between a real answer and an imaginary answer, other than the fact that one is a decimal, potentially, and one has an I? Well, it comes down to the graph, which is what we're going to be doing after this chapter, is graphing these. On a graph, every single one of these makes a shape we like to call a parabola.
Oh, yeah,
that would be the mathematical term for it. Either up or down. Every single one of these makes one of those. And when we graph these, we typically have 2 places where we hit the x-axis. Those are called x-intercepts. Yes? Every time our answer is real, those are the actual locations where our parabola hits the x-axis. Okay? If we get imaginary answers, then we have something like this going on where the parabola never actually touches the x-axis. So this is an example of 2 imaginary roots. They're called roots, they're called zeros, they're called solutions. You'll hear me say those things over and over again. So if it doesn't touch the x or y axis, or the x-axis, I should say, if it doesn't touch the x-axis, that means you've got imaginary roots. If you have 2 real roots, that means it touches the x-axis twice. There's one other scenario that could happen when you're graphing a parabola, and that is if it were to touch the x-axis not twice, but only once. Meaning that very bottommost point, or in this case the topmost point, is on there. So this one is 2 real solutions. This one you would get 1 real. Now I told you we were getting 2 answers every time, right? So I can understand the 2 imaginary, because that's just an I problem, and the 2 real. When would I get 1 real?
Isn't it when it's like 8 plus or minus or something?
If I had something like 8 plus or minus the square root of 0. What is the square root of 0? 0. So if I take 8 and I add 0, I get 8. And if I have 8 and I subtract 0, I still get 8. So when that square root ends up being 0, I actually only get 1 answer. That's the only case that I get 1 answer. So let's think about this for a minute. It all comes down to what's underneath the radical. If the result of what's underneath the radical is negative, what does that tell me about my answer? It's going to have an I. It's going to be that circumstance. Right? If what's under the radical becomes a positive number, I have 2 real answers, meaning I can actually see where those cross the x-axis. And if what's under the radical ends up being 0, then guess what? I have one real answer. So I don't really care about the radical so much as I care what's underneath the radical if I'm trying to determine what situation I'm in. Does that make sense? That's where the discriminant comes into play. So in the quadratic formula, what is the part that's under the radical? Isn't it b squared minus 4ac? That's what the discriminant is. We're going to solve that, and if that is negative, that means that if I were to go through the whole quadratic formula process, I'd be taking the square root of a negative number, which means I would get two imaginary answers. If I plug it into here and I get 0, that means I've got a situation like this where I would have one real answer. And if I plug into b squared minus 4ac and I get a positive number, I would end up with two real answers. So we're just trying to see which category do we fall into. Those are our only three possibilities. Okay? So I still need to be in standard form. I still need to identify A, B, and C. I'm just going to be plugging it into here instead of to the full-blown quadratic formula. Okay? Because it doesn't say solve, it says find the discriminant. And then state the number and type of solution. So we'll talk about that as soon as I get done with this one. Is this in standard form? Okay. So what is A? What is B? And what is C? Okay, so I'm not going to do the whole quadratic formula. I'm just going to do b squared minus 4ac. Okay, so let's see. Negative 5 squared is 25. Negative 4 times 6 is negative 24 times negative. I can just go to my calculator, can't I? That would be easier. Negative 4 times 6 times negative 6 is 144. And what is 25 plus 144? 169. So, when it says, when it says find the discriminant, I just did that. I just found the discriminant. So, if I were to do the whole quadratic formula, the negative b plus or minus the square root of b squared minus 4ac, this is the number that ends up underneath the radical. So what situation does that put me in? I have a positive number under the radical. Does that mean I'm going to be dealing with i's? No. I'm going to get two real answers, aren't I? So when it says find the discriminant, I did that. State the number and type of solutions. I'm going to say two real solutions. That tells me the number and the type of solutions. And that's all I'm doing. I just wanted to give meaning to it before I actually got into it. All right? How about this one? Is it in standard form?
Yes.
Okay. What's A? What's B? What's C? All right, let's do b squared. That would be negative 5 squared minus 4, 8, 8. Right? Negative 5 squared minus 4 times 8 times 8. Now, if you do it on your calculator, that's fine. At least show me that step right there as a bit of work so that I know you know what you're plugging in there. I get negative 231. That's the value of my discriminant. And what does that tell me about my solutions? Imaginary. Why? Because it's negative, and anything under a radical, because keep in mind, this is representing what's going to be under the radical. How many imaginary answers? 2 imaginary. So there's the number and the type of roots. And that's all we're doing for all these. b squared minus 4ac. If it's positive, tell me 2 real solutions. If it's negative, tell me 2 imaginary. There's only one case that we haven't done, and I'm hoping it comes up in one of the next 2. So let's look at this guy. What's wrong with this one? It's not in standard form. What do I need to do? Subtract 2 from both sides. That's going to give me 8x squared minus 8x plus 2 equals 0. What's A? 8. What's B? Negative 8. And what's C?
2.
So if I do negative 8, sorry, if I do negative 8 squared, my brain was going on the quadratic formula there, not the discriminant. Negative 8 squared, so that's b squared minus 4ac. Let's see what we get. Negative 8 squared minus 4 times 8 times 2. I got 0. Well, 0 is neither positive nor negative, so what does that mean? It doesn't fit here or here. What does that mean? That's my situation here where I have one real solution, like that. Okay, so 0 is the value of my discriminant. I have one real solution, meaning the vertex of that parabola is going to lie on the x-axis. Pretty easy? Okay, let's do this one. What do I need to do? Subtract 3. So I have negative 6m squared plus 6m. Uh-oh, that cancels out. So I just have equals 0? Okay, what's A? Negative 6. What's B? 6. Be careful. This one has an m, which means that's my B value, not my C value. This time it is C that equals 0. Yeah? Tricky, tricky. All right, B squared minus 4ac. What do I get? 6 squared minus 4 times negative 6 times 0. I should be able to do that in my head because anything times 0 is 0. So I just have 36. So there's the value of my discriminant. What does that mean about the number and types of my solutions? 2 real solutions. You think you get it? Okay. Why don't you take a minute and you tell me the value of the discriminant and the number and type of solutions for the last 4 problems there. You might need to move things around to get it into standard form first. Okay, but take a minute or two to do that. Out of curiosity, does anyone know the actual name of imaginary numbers? What they're actually called? Mm-hmm. They're called complex numbers. So if you hear the phrase complex numbers, that means the same thing as imaginary numbers. Just another way to call them. All right, I'm going to start off by adding 3. Is that what you got for standard form?
Yes.
A is 3, B is negative 6, C is 3, so B squared minus 4AC. Negative 6 squared minus 4 times 3 times 3. 0. That's the value. What does that mean?
Interesting.
One what? One real solution. Okay. This guy looks like it has quite a bit of moving around to do, doesn't it?
Yeah.
Now, I have a question for you.
You can move it farther.
I can. Why can't I?
Because, yeah.
You can or you can't.
I can.
Yeah. You have to move the other.
I can move this over here. Why?
It'll equal 0.
Because it'll still equal 0. The equal 0 is just on the other side.
Yeah.
Now, I'm curious about something, so I'm going to talk about it in a minute. What is A here?
5,
What's B?
8, negative 8,
And what's C?
7.
So if I do B squared minus 4AC, I get what?
Negative 76.
-76,
So it doesn't matter.
which means what?
It's two imaginary.
Two imaginary numbers.
How is it 2?
So it doesn't matter, right?
Now let me explain something here. Solutions. Because many of you probably moved everything the other way, didn't you?
Yeah.
You probably added 8p and you subtracted 7p. If you did that, you ended up with negative 5p squared plus 8p minus 7 equals 0. That is a different a value, a different b value, and a different c value, right? But they're only different in their signs, right? But if you do 8 squared minus 4 times negative 5 times negative 7, is it changed there?
No.
Minus 4AC, you still get negative 76. So it doesn't matter whether you move everything to the left or you move everything to the right. You're still going to get the same information. Okay? All right. Whew, this guy's got a lot. I'm going to move to the left because that means I only have to move 2 things, right? Whereas if I move to the right, I have to move 3 things. So I'm going to add 8k squared. And that gives me 10k squared minus 13k plus 8 equals negative 7k. And now I need to move what? I need to move the 7k. So 10k squared. Negative 13 plus 7 is negative 6k plus 8 equals 0. By the way, do you notice that every stinking time I do this, I write out that I'm doing it to both sides, and I don't just, there are a lot of people that they'll get in the habit of writing just, oh, I'm just going to do 7k to both sides, and they write that without saying whether they're adding or subtracting it. Do you get what I'm saying? Like in this step, they won't put a plus sign. They'll just write 7k. And so many times when people don't write the plus sign, or they don't write the minus sign, they end up doing the wrong thing there. So even me, after how many years I've been doing math, I still take the time to write the little plus sign or the minus sign because it guarantees to me that I'm doing the right step. Okay? So if you're a person who tends to get the wrong signs on things like that, make sure you're being meticulous like this and writing down what you're doing. Writing down that was a minus, I'm going to plus. And then write that down there so you don't forget what you're doing. All right, A is 10, B is negative 6, C is 8. So negative 6 squared minus 4 times 10 times 8. Negative 6 squared minus 4 times 10 times 8. The value of my discriminant is negative 284. What does that tell me about the number and type of solutions? 2 imaginary solutions. Okay, and this is about as hard as it gets. I mean, this is really the hardest type of problem I could give you for this. What am I going to do here? Yeah, we'll just move to the left. Again, it doesn't matter. So let's see. Negative 3x squared minus 9x plus 4 equals 10. Now what? Subtract 10. So negative 3x squared minus 9x minus 6 equals 0. A is negative 3. B is, and C is, we've got lots of negatives here. So B squared minus 4AC. Negative 9 squared minus 4 times negative 3 times negative 6. I get 9. What does that tell me about the number and type of solutions? Now, I could very easily say, then go find those solutions. If there's 2 real solutions, go find them. What would you do if I said to do that? How would you go find those solutions? You would actually use the full quadratic formula to come up with your 2 solutions. Okay? Remember, this is just telling me information about what those solutions would look like. If I need the actual solutions, you use the full quadratic formula. Okay? All right. Happy studying.